and welcome back to my chemistry channel, Chemistry for all my year 13 chemistry students. Today we are going to learn a very fascinating experiment on how to prepare a standard solution of potassium permanganate, and we're going to standardize it with iron ammonium sulfate. Now in this particular video you're going to learn the techniques as well as calculations that are going to be involved in such titrations. So my dear students and science enthusiasts, without wasting any more time, let's dive right into that. Welcome back students. So let's just get right into our experiment. But before that, safety is our number one priority. So we must ensure that we have our safety gloves, our lab coat, and not forgetting safety glasses. For this particular experiment, these are the glasswares that we will be using. We will need to have two small beakers to weigh our salts. We will weigh our potassium permanganate and our iron ammonium sulfate. We will need to have a measuring cylinder where we are going to transfer our concentrated sulfuric acid that will be mixed with our iron ammonium sulfate. We need to have a volumetric flask where we're going to keep our standard solution. In this case, our standard solution will be iron ammonium sulfate. Of course, we will need to have some conical flask where we will be transferring our standard solution into the conical flask for the titration. We need to have more than one or two conical flasks depending on the volume that you have. And to make the transfer, we will be using a pipette. So over here we have a 20 ml pipette, and to do that we are going to use a pipette filler. We need to have a wash bottle filled with distilled water and a burette, which is going to be clamped to a retort stand. So students, let's begin with our experiment. The first thing that we are going to do is to pour potassium permanganate solution into the burette. So I have already clamped it up here. Now we are going to dissolve our Fe2+, which is from iron ammonium sulfate, into concentrated sulfuric acid, and this is 20 milliliter. Now the reason why we are doing this is to prevent the pre-oxidation of Fe2+ into Fe3+. Okay, so once we have made a solution of this, we're going to dissolve this one to make sure that all the particles of Fe2+ are dissolved. We are going to transfer this into a volumetric flask and then make it up to 250 ml mark. So that is going to be our standard solution for this particular experiment. So now students, once our Fe2+ salt is dissolved in sulfuric acid, we are now going to transfer this solution into a volumetric flask. Okay, so now that we have made the transfer here, we are now going to add additional distilled water to reach up till this volumetric mark here, which is 250 ml. So now that our solution has reached up to the 250 ml volumetric mark, as you can see the lower meniscus is resting on the mark. We're now going to put a stopper to this and make sure that the solution is evenly mixed with each other. Now we are going to transfer 20 ml of this into a conical flask. So this is a 20 ml pipette that I am using. Okay, so this is my 20 ml of the Fe2 plus solution, which I am now going to transfer into the conical flask. Okay, so now that I have transferred 20 ml of the Fe2 plus into the conical flask, I'm going to take this up to titrate against a potassium permanganate solution. Now we have to remember that we know the concentration of this chemical here, we know the volume that we have taken, therefore our primary standard is going to be used to calculate the concentration of potassium permanganate solution. So now that we have our Fe2 plus solution here, we are now going to titrate it against our potassium permanganate. So I have already recorded my initial volume, which is 3.1 milliliters. Now I'm going to titrate it against the Fe2 plus. Now the reason why we do not add any external indicator is because potassium permanganate, apart from being a strong oxidant, is an indicator itself. So it will change color to a persistent pink, and that is where we are going to stop the titration, and that's going to be our endpoint. During the course of the titration, you may notice that we will have some potassium permanganate that will stick to the side of the conical flask. So to ensure that all the particles are going into the conical flask, we just use distilled water to run against it. Okay, so this is the color that we have obtained at the end point. As you can see, that is a very faint pink color, and this is where we are going to stop the titration and record our final volume. So once we have the final volume, just lift it up to eye level. So my final volume is 31.7 milliliters. So we started off with 3.1 milliliter, and now we have 31.7 milliliter. The difference is the titer that has been used up. So now we are going to repeat the titration so that we get concordant results, and using the average concordant values, we will find the amount of the analyte that was used up, and using that we will calculate the concentration of our potassium permanganate solution. So students, now after we have done our titration experiment, we are now in every calculation, it is vital that we write our information so that we have a clear understanding of our variables. Now, beginning with step number 1, we're going to calculate the moles of the primary standard. Recall that we have already calculated the concentration of Fe2 plus while we were preparing our standard solution, and then we determine our moles. Using these moles, we are now going to move into step 2, where we're going to use a mole ratio to calculate the moles of the analyte. Now, as you can see, according to the balanced redox equation, 1 mole of permanganate ion required 5 moles of Fe2 plus. And in doing so, when we do our mole ratio, we get our moles of potassium permanganate as such. Finally, using the moles that we had determined in step 2, we're going to calculate the concentration of the analyte. So it is moles divided by the volume. And as you can see here, how our variables have changed. Now, we are going to present our answer in 2 decimal places. So students, that's it for today. I hope you have found this helpful. Remember to review the main points. And if you have any burning questions, do not hesitate to ask me and put it in the comment section. Until then, keep up with the great work and I'll see you in the next video. Bye!